Well, well, well. Welcome to the Daily Space Weather. It's been another exciting day. You might see a bunch of activity happening up there in the northeastern portion and the central portion of the solar disk. It's enough to make you break out your sunglasses. And the exciting times will continue here at the Smash News Network, least busted name of news. We're delighted that you've found the channel. Congratulations on realizing it exists. Don't mind us. We're just bringing you the most detailed solar imagery and comprehensive space weather in the known universe. This is the past 24 hours from SDO. And it is a filament fest. Perhaps for the record books. So you might see some filamentary activity going on up here. We recently named this filament that's leading this active region. It's called the Edward C. Scott filament, the father of Voyager 2. Shout out to our viewer who decided to name that. Here's a sort of a view of the Northeast. You'll see definitely some serious plasma reorientation going on. It's quite spectacular imagery indeed over the past 24 hours. We've got no shortage of it today. So, put on your space helmets, your chrome shirts, your radiation-reflecting hats, and enjoy the ride. Huge filament down here. It's called the Sundar Pichai filament, and it looked like it was going to eject. I believe it is still intact. We also had a tsunami generated by a 7.7 magnitude earthquake in the Western Pacific. We'll get to it. We've got a four corners situation going on, but the most exciting corner is the Northeast. We're going to have some new sunspots likely named today as well. We've seen a little uptick in solar activity over the past 24 hours. So here is yesterday plus today. That is your SDO intensity gram. We've got a high probability of solar flares in especially the northeastern and northwestern limb. Also significant possibility in the southeastern and southwestern limbs. Like I said, it's a four-corner situation. We could see large flares from any of those locations. The most likely place to see a large flare, however, is probably this sunspot group up here. We've even seen the background level of flaring rise. Let's take a brief moment to turn our attention to Crescent Earth. Yeah, Crescent Earth. We've got volcanoes erupting. Etna doing some degassing and a bit of a seismic crisis happening there. Ground shaken as gas comes out of the Etna volcano on Sicily. Mount Etna erupting. Semeru also erupting. Flight level 150. It's a 15,000-foot ash plume. Popocatépetl in central Mexico. Flight level 220. That's a 22,000-foot ash plume. Not sure if Sangay is erupting in Ecuador. Please don't pole vault the caldera. More on pole vaulting the caldera later. If you're going on a volcanic vacation, leave your vault pole at home. Revenador is also exploding. Flight level 150, flight level 230 over Peru from Sabancaya. As it explodes, it's a 23,000-foot ash plume. And check it out. There was a 7.7 magnitude quake near New Caledonia. There is the shake map for that. That came in early this morning at 2:57 Universal Time on today, May 19th. If you're wondering if tsunamis were generated, the answer is yes. Now, the largest tsunamis, I believe, were only 1 foot or 0.3 meters in height. But there were some tsunamis reported. If you want to go check them out yourself, check out tsunami.gov. Here's some video of somebody in the South Pacific. Perhaps Hawaii, having reached higher ground, keeping a lookout. Again, the largest tsunamis reported were only 1 foot, so no major events there. And let's take a look at the map to report quakes over a 5 magnitude. So first of all, we have a 5.1 at the South Sandwich Islands. What do you think about this view? I like it. All right, so yeah, 5.1 of the South Sandwich Islands. That was 11:56 Universal Time yesterday. Again, we'll cite quakes over a 5 magnitude. Let's hope that 7.7 was not a foreshock. Greece had a 5.2. That was at 18:58 yesterday evening on May 18th. So there's that 7.7. Again, that was at 2:57 Universal Time this morning on May 19th. And countless aftershocks of a 5+ magnitude. We won't even cite those. That is a lot of shaking going on. Things finally calming down there a little bit here. Still seeing quakes above a 5 magnitude there. Earth's shakiest location, near the Loyalty Islands, southeast of New Caledonia. By the way, there's a paid endorsement associated with this video. It's our Hemp Lucid shop. So if you've never checked out the Hemp Lucid shop, check out the links below the video, as well as on our homepage at smashomash.com. Today's featured product is the most popular, the organic full-spectrum water-soluble CBD. It comes in natural mint or orange flavor. Tastes great, less filling, and don't forget to enter the promo code SMASHOMASH to save some cash on checkout. 10%, indeed. You can find links on the homepage at smashomash.com as well as below this video in the description. Pick up your CBD products, mushroom gummies, and more via our Hemp Lucid shop, shop via our link, or enter the promo code SMASHOMASH to save 10% on your checkout. Thanks to everybody who has been supporting the channel and perhaps improving their own health with the products. Our homepage is smashomash.com, the official homepage of the Smash News Network, least busted name in news. If you are unable or unwilling to support the channel by becoming a member of the Smash team or picking up some merch products or something like that, help us out with clicks. Visit us on social media. Press the share button, comment, like, etc. Thanks to all of the interactions that we've been seeing in the previous days. Yes. Thanks very much to each and every one of you for tuning in to the content. The 10.7 centimeter radial flux has now risen to 151 solar flux units, and I'm expecting it to continue to rise here as we're seeing more sunspots behind these major groups that have just risen in the east. We'll get to it. There's the 1-year graph of the 10.7 centimeter radial flux represented by that black line. The red line is the sunspot number, and the radial flux number here is now toying once again with this support zone. So you can see right around here for the last about 7 months, we're seeing this support level around the 150 solar flux units. So we're just waiting to see the sun break out here. We are still expecting there to be like a year until solar max. So you can expect activity of this level for the next about 2 years. Next, we'll look at the Space Weather Enthusiast dashboard here. This is the NOAA forecast for space weather, and no major space weather on the forecast. They are calling for geomagnetic unrest late in the day on the 21st. That must be a result of a coronal hole high-speed stream. Besides that, no major space weather in the forecast. And let me actually refresh this one. This is the NASA forecast. I just want to make sure that we have the latest data here for you because we show it so that you have the latest information. So let me bring up the, let's see, we want the inner planets view. There we go. NASA agreeing here, no new coronal mass ejections headed Earth's way. Let's look at some of the local stats here. Here is Earth's magnetic moment from space for the past 4 hours. This geospace magnetosphere movie depicts magnetohydrodynamic pressure as modeled by the space weather modeling framework. It uses things like magnetometers at Lagrangian point 1, the solar wind speed and density, magnetic fields, electron flux, and a lot more to determine this model. Things are geomagnetically calm in the Earth system. Here's Earth's magnetic moment from the ground for the past 4 hours. The ground magnetic perturbations map depicts changes to Earth's B field in magnetic flux density, the units of which are nanotesla. That's the last 4 hours of Earth's magnetic moment from the ground. Again, it's a geomagnetically calm situation here. KP index is currently at 0. KP index is at 1. KP1 is the current situation. And let's go to the real-time solar wind next. Solar wind speed here quite slow. 336 kilometers per second for the solar wind speed. Solar wind density quite diffuse at 3.7 protons per cubic centimeter. Remember, folks, never report on a data set unless you're reporting the units. Thanks for leaving comments, John and Robert. Good morning to you dudes as well. Coronal hole high-speed stream on the way. You can expect that in about 2 days. Here are our GOES magnetometers. Those are measured from the geosynchronous near equatorial orbits of the GOES 16 and GOES 18. The altitude there is about 23,500 miles. Fairly smooth readings there from the GOES 16 and GOES 18 magnetometers. And let's take a look at the plasma. There is our top view ecliptic plane field plot that depicts the polarity of the heliospheric current sheet. And Earth is right near the middle of the South Pole current sheet there, depicted in red. Welcome to the South Pole, the South Heliospheric Magnetic Pole. And let's take a look at the line of sight field plot next. There's your line of sight field plot. You can see that fanned out B field there in blue. That's the sun's B field, the field that goes through the magnet. This magnet being the closest star, El Sol, aka Helios. Next, we'll look at coronal holes. They're kind of important. And let's bring up some imagery here as we've got some more imagery than we usually show. So we've got an inordinate amount of movies today. Here's another one. This is 131 plus 171 angstroms because, well, we wanted to show you some additional features here. So let me get off screen as there are some serious money-earning shots. Let's get even closer to that. And that is an epic view in 2 wavelengths there, the 131 plus 171 angstroms. So here's our coronal hole wavelength. That's the 211 angstroms. You can see very well-defined coronal holes here. In the southeast, those are of South Pole orientation. Let's bring up the last image here. There you go. South Pole-oriented coronal holes here dominating the Earth-facing portion of the solar disk. So these are all South Pole. This is South Pole. These are South Pole. Even this one is South Pole. And that brings us to sunspots. We're going to have some new named sunspots. We'll have 3312 down here and 3313 up here, I think. I believe there are additional sunspots trailing 3310 and 3311. So, yeah, we're expecting an uptick in the sunspot number coming today. There appear to be additional groups there. And let's take a look at some imagery here from SDO. There's the SDO continuum. That is a 24-hour video. So you can see a new group rising here to the southeast of this group, 3310, and there are additional sunspots behind 3311 also. So this group here, the series of groups actually, as that approaches the limb, those groups become more likely to produce large flares. That's why I talked about the four corner situation. The possibility of large flares in all four corners of the solar limb at the moment. It's a perfect opportunity to see excessive amounts of solar flares. So here you can see this new group rising behind 3310. That'll get a name. That'll probably be 3312. And then up here, I think there is another group rising behind that also. So that one might be a little bit early to call that, but that is the most likely place to see an X-class flare at the moment. And yeah, possibility of large flares is super high. Anyway, let's move on to energetic particles and solar flares. The proton flux here has returned to its baseline following a minor event associated with a decent-sized M-class flare. And since yesterday, there have been a series of M-class flares, including this long-duration one, and then a few other pretty long-duration ones as well. This one here had a nice double peak. Largest flare of the past 24 was at about 0 dark 50 there. 50 minutes after midnight Universal Time, it was an M5.39. That's a decent-sized flare. And let's take a look at the flaring. It came from this group up here. Perhaps no surprise, especially since we were streaming it all day yesterday. So here's 131 plus 171 angstroms. It's pretty sweet. Yowzers. And here is 131 plus 94 angstroms. These are the two optimal wavelengths through which to view solar flares. They take more images than the other wavelengths from the SDO. There's a fantastic 24-hour SDO video depicting two different species of ionized iron and a series of large M+ class flares. Exciting times for space weather. And here's an equatorial view again. Quick reminder, there is a possibility for large flares at all four corners of the solar limb. Shout out to Eugene the Philosopher. If you haven't subscribed to his channel, subscribe to Eugene the Philosopher. He's writing a paper about the anisotropy of solar flares. Eugene the Philosopher, Philostopher, the greatest living philosopher since the unfortunate passing of Quentin Robert to Nameland or something. We're going to get to things like CMEs here in a moment. First, let's take a moment to orient ourselves. So this is what's going on over Lehigh Valley, Pennsylvania at the moment. You've got the sun only a few degrees off the horizon, and also the new moon there, quite close to the sun, not particularly visible. And here's your solar system forecast. Happy new moon. We hope all of you reverse werewolves are sleeping well, being productive members of society, not cannibalizing humans or worshiping Satan. All right, now that I got that out of my system, let's advance this 1 week to show you the 1 week solar system forecast for your favorite heavenly bodies. That's where things will be in a week. And let's take a look at coronal mass ejections. Here are yesterday's coronagraphs. And those, my friends, are not Earth-directed coronal mass ejections. That's 96 frames from yesterday. Here are an additional 28 frames from today. Some more minor CMEs and outflows happening there. Nothing too exciting. Here's your auto-refreshing LASCO coronagraphs. Again, those CMEs do not appear to be earthly directed. Let's take a look at some of our custom 24-hour videos. Let's take a look at stereo A, as well as Soho LASCO C3. Here is stereo A on the left, Soho LASCO C3 on the right. Keep in mind those frames are not synced. Pay attention to the time and date stamps at the bottom. So some coronal mass ejection activity there, nothing apparently earthly directed. So let's zoom in a little bit closer on our custom 24-hour view. This depicts the SDO 193 angstroms wavelength. And the story is filaments. I mean, there are an incredible number of very large and very dense plasma filaments. You'll be able to see some of the indications of those in the 193 wavelength, 193 angstroms wavelength here. You can see a bunch of dark absorption features. This is the Edward C. Scott filament. This is the Sundar Pichai filament, and a bunch of those filaments could use names. If you want to name filaments, do it on Twitter. Follow the hashtag #NameThatFilament. Follow us on Twitter even if you're not interested in space weather. Just follow us on Twitter because, well, we talk about stuff besides space weather. And let's take a look at filaments here in some additional detail. So this is the ground-based solar observatory at El Teide, Spain. It depicts hydrogen alpha, the emissions of hydrogen. And when you see these dark features here on the solar disk, those are plasma filaments. Now, I guess I named this one well because this one is still intact. And I specifically named that one because, well, the viewer wanted this one named, but it's already got a name. So we named this one instead because since it's so close to that really active sunspot, I figured a good idea would be to name that one, as it could indeed cause a geomagnetic storm if it does strike the Earth's magnetosphere. So anyway, another good filament to name would be this one down here. Again, follow us on Twitter. Thanks to all of our Twitter followers. And let's bring up the last 24 hours in SDO 171 angstroms. It's the house favorite. And if you've been waiting for this wavelength, well, it was probably worth the wait, as this imagery is just splentacular. Again, it's a four-corner situation. We could see a large flare from any of the four corners, the most likely one being the northeast, which would be the upper left, as sunspot 3311 is indeed an exciting sunspot. And that, my friends and foes, is some spectacular imagery. Anyway, here's the past couple of hours, and the Filamentary Fest continues here as there is a lot more to happen. We'll be monitoring it throughout the day once again in another extended live stream right on YouTube. The Sundar Pichai filament is looking pretty unstable once again. And maybe this video is worth $226 million. Let us know in the comments what you think. Let's continue on to our bonus features segment. We don't want the video to be too lengthy. Satellite's community dashboard is not showing any charging hazards. It's clear sailing for satellites here. No charging hazards of the internal or surface charging variety. The GOES electron flux is just in a fairly low range here. Let's see what the NOAA forecast is after we show the 1-year graph. There's the 1-year graph of the relativistic electrons. Keep in mind those are measured at the F layer of the ionosphere. And you can see NOAA expecting a little dip here in the electron flux. Sounds consistent with a coronal hole high-speed stream impact to me. No arguments there about the forecast, which is the green boxes. The yellow diamonds are the observation. We'll show the F layer of the ionosphere in vibrational frequency. Feel free to pause the video on this frame if you're not familiar with penetration of electromagnetic radiation, thermospheric temperatures, and molecular concentrations. Here is the F layer. We showed some interesting low-frequency anomalies happening yesterday around Oceania, the southern Indian Ocean, southern Atlantic Ocean, etc. Let's see if those are persisting, as we couldn't directly blame space weather for that yesterday. So we'll let that play through, and then we'll show the anomalygram. So that was the raw vibrational frequency. This is anomaly in megahertz from the 30-day median. And once again, we are seeing lots of low-frequency anomalies hanging out there in the southern Indian Ocean, southern Atlantic, southern Pacific, really the southern hemisphere in general. So significant low-frequency anomalies showing up there despite no major space weather happening. So this is an effect, a local effect happening on planet Earth. And let's bring up the latest image. There is 11:15 Universal Time ionogram and 11:15 Universal Time anomalygram. Congratulations on surviving another week, almost. Next, we'll show the total electron content. That'll depict the most likely places to see GPS errors. Feel free to pause the video on this frame if you're not familiar with distances to these things in miles. Here is your total electron content forecast. Shrink that down one size so you can see the progress bar. Turn on your Wi-Fi location accuracy if you are having trouble navigating using GPS. We are seeing some significant GPS errors here. So I would expect to see some major ones when the coronal hole wind stream arrives as well. You can expect some GPS errors from that. We typically see more electrons out of place. More electrons out of place when we have low electron flux. So this depicts a total electron content. It's a count of the free electrons to about 12,500 miles of altitude. Here's a total electron content anomaly from the 10-day average over North America. As if we're going to start attempting to forecast earthquakes on this channel, we're going to start doing it around U.S. fault lines. But at the moment, it's really just not a priority as we are approaching space weather from a cosmology perspective. We're interested in space weather as a puzzle piece. Heliophysics will advance the science of cosmology. We're striving to make astronomy and cosmology science again. However, if you are able to actually forecast earthquakes, we are quite interested in this. We just haven't seen anybody actually doing it yet. Just correlations. I'm not convinced of any predictive value. We'll close out the space weather section with the latest magnetogram and latest STO intensitygram. So, this group over here, as it gets closer to the limb, it becomes very likely to produce large flares, including the X-class type of flares. This group here becoming more likely to produce large flares. And these groups in the east, they're actually becoming less likely to produce large flares. So there's a second group. That'll be 3312. This is 3310. This will be 3312. This group is capable of producing large flares. This group is much less magnetically complex. And the biggest flare player continues to be 3311. There's 3313. So like I said, there is another sunspot there behind that large and active sunspot group. So there is your SDO magnetogram and SDO intensitygram. This sunspot group is beta gamma delta class. This group down here is beta gamma class with small little tiny deltas there. This group here, that is beta gamma class barely. This group here looks like it's beta gamma delta class. This group up here is certainly beta gamma delta class. Check out the magnetic complexity there on that leading sunspot group. 3311 is a star among a star. Let's move to meteorology. And what are we looking at here? 64 mile per hour winds there in the Indian Ocean. Those are the strongest sustained winds in the world right now. Almost smack dab in the middle of the Indian Ocean. So that's just the surface winds there from nullschool.net. Check out nullschool.net if you're looking for global weather patterns and things. It's quite a tool. These are the surface winds of the east. These are the jet streams of the east. The jet streams of the central world, Europe, Africa, and the Middle East depicted here. Surface winds depicted here. It's windy times in North Africa and in the central Mediterranean. Here are the surface winds of the western world. It remains windy in the North Atlantic. Looks like a bad day for Viking raids once again. And here are the jet streams. Like sands through the hourglass of time, these are the rest of the weather data of your lives. This is clouds and fog over the Americas. We like to use the 3.9 micrometer radiation map to figure out if the aurora will be visible when geomagnetic storms arrive. At the moment, none are likely. However, at least we have an idea whether or not it will be cloudy or foggy at nighttime via the NASA GOES Interactive Weather Satellite Suite. Here's your weather.gov map. If your location is lit, head to weather.gov and click it, your location, so you can get your weather warnings. We'll scroll down briefly to show you the key. Looks like a lot of air quality alerts there in the north central U.S. Weather.gov is where to go. Shout out to Reed Timmer, by the way. We watched Reed Timmer chasing tornadoes last night. It was fantastic. Reed Timmer. Great YouTube channel there. One of the country's most prolific storm chasers. Here's your temperature anomaly forecast, since we do have some temperature anomalies going on here. Cold temperatures coming to the south central U.S. and hot temperatures coming to the northwestern U.S. That's a 72-hour GFS temperature anomaly forecast in degrees Celsius. We'll also show the GFS 72-hour pressure and precipitation forecast depicted here. Strong storms to move up the U.S. East Coast, and some strong storms developing around Texas and Oklahoma, as a band of moisture will stretch all the way from Mexico to Quebec. Next, your lightning mapper, and check out the lightning off the East Coast and in the central U.S. Quite a bit of lightning here over the past about 10 hours. Also Central America and South America seeing some extreme amounts of lightning. The Western world there, lots of lightning going on. And remember, folks, lightning does strike twice. Don't assume that because lightning struck an area that it's not going to strike it again. It could be because of a conductor, perhaps a magnetite deposit in the ground or something like that. We've got some very strong lightning here off the coast of Florida, Georgia, and the Carolinas. Looks like some good surf at Charleston. Wait a minute. Maybe not. Does Charleston even have a beach? It's just a giant swamp, folks. All right, anyway, that's our real-time lightning map from lightningmaps.org. Next time you hear thunder, check it out. Hey, Tulsa, there's thunder rolling in from your west. Quite a bit of lightning at the moment here on planet Earth. We're going to show you the U.S. Doppler radar map. We're going to show you the windy.com map. Because here at the Smash News Network, Least Busted Damon News, we are interested in your intake of facts. So here's our windy.com map. And if you've got any requests as to what layer to show, let us know in the comments. Let's look at, let's see, what can we look at here? How about high clouds? Really cool feature of windy.com is that you can look at high clouds, medium clouds, low clouds, fog. You can look at cloud tops. That'll show you the variation of cloud top altitudes. They've even got sea surface temperature on the map. There's the Gulf Stream. Windy.com. It's super good. Free mobile app. We're not even paid to say it. And we're not paid to say, do not pole vault the caldera. Actually, we are, because people pick up the merch. By the way, thanks to everybody who has picked up the merch, helped to advertise the channel, start conversations. They make great gifts. So if you're planning a volcanic vacation, leave your vault pole at home. Our finest days lie ahead. So, although things might seem badly, and although they can certainly get worse, if you're going through hell, keep going. Don't pole vault the caldera. It could be unhealthful. Don't go the way of Steve Stimpak, who died in an unfortunate table tennis accident after retiring from his caldera pole vaulting career. Steve Stimpak, the original pole vaulter of caldera. Don't do it, folks. It's bad for the kids. Don't encourage the kids to pole vault the caldera, and don't do it yourself. But do visit our merch links, which are below this video and on the homepage at smashomash.com. Today's featured product is the King Kamea Hawaiian shirt, which, well, I'm currently wearing. So, in your trips to space, make sure that you are dressed properly. Have your chrome shirt, your chrome pants, your chrome radiation reflecting hat. You can find links to the Amazon shop below this video as well. A bunch of products there under Spaceware. We've recently added a bunch of camping supplies. Last but not least, if you want to support the channel via subscription services, consider becoming a member of the Smash Team at smashomash.com/Smash Team. Thanks very much, Smash Team. As we have upgraded our system here, the new PC is working out splendidly. It's greatly increasing our capabilities and the quality of the content. So smashomash.com/Smash Team. Join at the gold or silver level. The best value is a gold annual paid-up subscription. Additional content available to Smash Team members. And let's close this mother out with the U.S. Doppler radar. Now, the U.S. Doppler radar, what that's depicting, folks, it's depicting vertical motion of water droplets in the air column. So, now, sometimes your Doppler may appear to be wrong. Yeah, it appears to be wrong sometimes, right? Sometimes you look at your Doppler and you go, "What? It's showing rain, but it's not raining." It's not because it's wrong. The reason it's showing rain and not raining at the ground level is because it's correctly measuring vertical motion of water droplets. Those droplets just aren't making it all the way to the ground. So that's, I mean, it happens really often here in Pennsylvania during snow. So just so you are aware of that, you know, if your Doppler is lying to you, it's not because it's wrong. There is vertical motion of water droplets or ice crystals there. They're just not making it to the ground level. Anyway, there's our full 50-state view. We have some precipitation at both Alaska and Hawaii. And the strongest system here is moving toward Missouri. So Missouri, you're in the crosshairs. St. Louis and Kansas City, later Indianapolis, can all expect to get hit today. Here is your clouds and fog over the U.S. Once again, that's a 3.9 micrometer radiation, the shortwave radiation animation map. And here's water vapor. So you've got a blocking feature here. So this is a great example of dry, cooler, and more massive air coming down and causing this system to want to move to the east. That's an effective high. This is an effective low, and you can see it's kind of making a turn. And that's because it has only one path of least resistance, which is taking it up toward Lake Michigan. So that's what's going on. And, you know, for you new viewers out there, dry air is more massive than moist air at a given temperature and pressure because of the molecular mass of nitrogen, N2 versus H2O. Nitrogen is more massive than water vapor, meaning it weighs more. Anyway, there is your recap. U.S. Doppler radar, shortwave radiation, and water vapor. Looks like clear skies over most of Georgia. Anyway, it's time to close this thing out. Thanks for tuning into the Smash News Network, least busted name in news. Once again, congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.